thing is amazing. Do you ever score on it? What is this? You're shipping this tomorrow to Australia, but what is it? What was the idea behind it?
So we were challenged to build a robot that could play air hockey against a human, and it was originally built for the Freescale Technology Forum, and we had 9 weeks in order to build it. And so it was a quick build. So we used largely off-the-shelf systems. So we used an off-the-shelf industrial robot. We got a visual analytics system. And then we modified an air hockey table, and it's engaging because every human walks up just as you did, and they're like, "I know how to play this game, right? You know, I'll show this robot a thing or two," and they get into it, and the robot is so precise about what it does and so fast. It's really hard to beat. So we had the number 12 national player in the world come here to play the robot, and it was funny because the system was coded originally by 4 firmware coders. And none of us were really air hockey players. And so the first time he showed up, he walks up and he says, you know, will the system handle a double tap? Well, I don't know what's a double tap, right? So he gives it a little slow hit, and then just as it's crossing the center line, he hits it really fast a different direction. And we're like, oh, I didn't know we could do that. We didn't code for that. All right. So we're like, all right, do every move you know, right? And we're recording this match every 9 milliseconds. So do every single trick move you've ever done, you've ever seen anyone do, just, you know, so he plays the robot for hours. We record the whole thing. We're like, all right, go away, come back in 2 weeks, right? So he comes back in 2 weeks, plays the things for 2 hours, can't score. And he's like, you bastards, I've been playing this game for decades, right? This is totally unfair. And in 2 weeks, you guys learned every trick move I know.
So you had 9 weeks to do this. You did that in no problem. But what was the biggest challenge in that design process?
The biggest challenge in the design process was the physics of basically understanding the path prediction. So it's interesting, when a puck hits a wall, it's not an optical collision. It doesn't bounce off directly the other way. It actually does something slightly different and imparts a spin. And then when it hits the next wall, it spins a different way. So you'll see on the top of the puck, we actually have a rectangle. And the purpose of that is to be able for the video analytics to capture the spin of the puck in any given moment. So we can, while the puck is moving around the table, the video analytics system can see the rectangle here, and it calculates not only the XY trajectory, and it can calculate up to 3 bounces ahead, but actually calculates the spin as well. And then the robot, analogous to a human, keeps a % confidence factor. And so based on how confident the robot is in what's going on the table, basically how well reality is tracking to its model, it'll play more and more aggressively. And so when you see it venture out and take really hard shots against you, that's when it knows where the puck is and where it's going.
You guys did this half seriously and half because it was a fun engineering project to do. But in the backs of your minds, as an engineering services company, you're thinking, what can I apply from this into our real world stuff? Was there anything from this design?
Sure. So I mean, the simplest is this is a product that's available for purchase from Nuvation. So we have this one that we bring to trade shows. We have a permanent install at the Carnegie Science Center, and then we have we've just sold another system to Australia, and so this is, you know, the third system that we've sold. And then it also allowed us to combine, you know, some really tough video analytics problems with precise control of an electromechanical system. This is an industrial robot. You know, it's designed to do the same welding mechanism over and over again. So we actually had to hack into the code a bunch in order to get the real-time control that we need for something like this. Because we're not moving from point A to point B. You know, we need to react continuously as the gameplay goes.